So hello everyone, welcome back to MindMatrix. In today's video, we will be solving questions based on conditional probability. I hope you have seen the last lecture where I have, formed the foundation for the conditional probability, which is going to be very useful if I talk about Bayes theorem, and then there would be independent events we will be discussing. So that really forms the, foundation for discussing all those topics. So, and I hope you are liking this complete series where we have started probability from scratch. Okay, in fact I have started with basic counting principles. Okay, though I have not made a lot many videos on that because counting is not that important within probability. It is just important, so you should know basic stuff. And after that I have covered the basic of probability, what exactly is it, the interpretations related to it. After that we had different videos on laws, axioms and all that. So we are covering everything from the scratch. I hope if you are following, you are getting comfortable with the concepts within the probability. And I am I'm definitely sure about it. You wouldn't be getting this much of content anywhere. You won't be getting for sure. Okay, wherever you will be studying, this is going to be very rare because I know like how many books I'm referring to for uh, creating these kind of videos over here for the questions and for the content as well. Okay, so let's start guys, and yeah, give me a thumbs up if you're liking these series. Okay, so here's a quick intro. You already know about me. I won't be going in the detail over here. So yeah, just one thing. Like, I'm Sachin Tanwar, and welcome you all to the MindMatrix. So let's continue further. So this was like for the last video. So as I mentioned that we will be having some sample questions because I don't want any video to go beyond 1 hour or 45 minutes. So that's why we stopped there. So now we'll be continuing with this. Okay. And this is the question which is being asked in your sample paper by IISc Bangalore. Okay. So we'll continue with this problem. And we have 3 problems only. This video is going to be not that long, but still. Okay. So let's just start doing this. What exactly we are having? Okay, let's see. Why am I not getting a pen over here? Is there any issue? Okay, let me just see. Yeah, I'm having it. So yeah, let's see this. So we have this question over here. Yeah, which was being asked in your sample paper. So let's just discuss. So we have n particles and it is given we have m boxes. So it is similar to kind of, the distribution problem. We have already seen that how do we do that. Okay. So it is just one of a kind of that problem where we have to calculate the corresponding probability. So we have n particles, m boxes, and it is given to us that m is greater than n. M is greater than n. So this is like important. Okay, we place each particle in one of the boxes. Basically it is like we are having some objects which are like n objects we can say, and m is the number of boxes which we are having. And we know, like, yeah, we already know m is greater than n. Okay, and randomly we are putting these objects or particles in these boxes. What is the probability that no box receives more than one particle? No box receives more than one particle. That means I don't want any object receiving more than one what or particle. So that may be a case that, okay, if I'm putting a particle or an object in a box, then I'm not going to put more than one. But there may be a case that some boxes would be empty, that I'm sure about it. Why? Because I already know m is greater than n. And if I'm just keeping one, when I'm putting one of the particle or one object at a time in a box, then I'm not keeping more than one. So it's like this only. Let's suppose m is 5, just for an example. And let's suppose n is equal to 3. So we have kind of, 5 blanks I'm having. And I have to keep these particles or objects within these 5. So what I'll do is, I won't be doing something like this. I cannot have this. Basically putting 2 objects or particle within one box. This is not possible. So what is going to happen? It would be something like this. Okay. It is going to be something like this. Let me just erase this. So something like this. So over here, and over here. It could be like this, or it could be like this, or it could be like this. Anything. Like I have created, these are three different levels I have created just to give you an example within same, that how we can go about these. Okay, I hope this idea is clear, that how we are, going to put these. How am I going to put these? So let me just put a straight line over here so that you can get this side straight. Okay. So yeah, something like this. So either I'll be having like, this can be one of the, way I can put, or this can be another way, or this can be another way. So there will be a number of ways I'll be doing it. The thing is, I won't be putting more than one particle or object in a box. I hope that this is for the students who take time in understanding these problems. So what is going to be the number of ways? And one important thing over here is, this is not being mentioned to us that, okay, that these are different particles or identical particles, or boxes are different or boxes are same. So over here, the assumption is going to be that we are having different particles and different boxes. Okay, we are having different particles and different boxes. Because if I talk about, putting five and five, putting three objects in five boxes and nothing is mentioned, so either it should be all identical or it must be all different. So if it is identical one, so like the answer is going to be, the way you can just break it down into three parts, so that is going to be, the answer is going to be one for that. Okay, one for that. For this one, basically, if I talk about the way I can put each of the particle in one box, so such that no box receive more than one particle, because I'll be just separating them in a way. I'll be just separating them. I'll be putting one in each, and such that two boxes will be empty. So there will be one way for that. And if I talk about how many ways I could put, so how to do that, we have already seen. So it would have been, if the way I could divide 3 into maximum 5 parts, which is not possible because the number is already less than 5. So what could be the way? It would be either 3 in a box, or 2 1, or 1 1 1. This could be the way. So in the denominator, the value could be 3 and the answer would have been 1 by 3. Simply this would have been the answer if the case would have been that all the boxes and all the particles objects are identical, are same. I hope the idea is clear. Let me just repeat once again. If this would have been the case that all the boxes and all the particles are same, then what is the what is the probability that no box receives more than one particle? So there is only one way I could put, particles or objects within these boxes. That would have been, just pick any box and put the particle or object. Put any box, pick any object. What I'm saying, pick any box and then put any particle or object within that. And you won't be repeating the number of particles within a box. So that is going to be very random and you need not to think, because all the boxes are same, all the particles are same. So that is going to be only one way if you want to, make sure this thing. But if I talk about the total number of ways you could have put, so just remember the case of distribution, the last case, okay, that you must know how you can divide the number of particles or objects into maximum 5 parts. If the case is over here, what your m number of boxes you are having. So this is I'm taking with respect to this thing. Okay, m is equal to 5, n is equal to 3. So then this could have been the answer, that you the maximum number of ways in which you can divide 3 into maximum 5 parts. So this could have been the stuff. So answer would have been 1 by 3. Now if I talk about m and n case, so there is going to be some different kind of formula which you have to use, but definitely as we can see kind of factorial notations are coming. So this is not the case. So that means these are different. Okay, I hope you are getting why we are going up with the case of that the objects and boxes are different over here. Okay, so let me just remove this and consider the case when these are different. Okay, so if these are different, then what would be the answer? So it is going to be very simple again. So it is like you have 5 places. You have 5 places. Again, the value I'm taking is m is equal to 5 and n is equal to 3, so that we can further come back and generalize. So the way would be that I will select 3 places out of these 5 places. What I'll do, I'll select simply 3 places out of 5 places. So it would be 5C3. And then I can arrange. Let's suppose I have picked up this, and this one. Let's suppose I have picked up these three. Now, because my objects are all also different, let them be A, B, C. So I could put like A, B, C, or it could be B, C, A, or it could be C, A, B, something like this. So there will be how many number of ways in which I can, put these objects within these 3 locations? 3 factorial. Okay, so this is the number of ways in which I can put these particles or objects within the boxes, such that no box receives more than one particle or object. Now, what will be the denominator? What will be the total cases in like the number of ways in which I can put these particles or objects within these boxes? So it is like very simple. For each of your particle or object, what is the number of choice? That okay, where can I put this? This can be placed within first, second, third, fourth, and fifth. So this have like 5 ways I can put this. Again, for this one, I have again 5 ways, because I'm talking about the sample space where these can be put. Okay, so this also can be put in any of the boxes, because we want to be considering that okay, that one box cannot contain multiple, because I'm talking about the sample space, total ways in which I can just put these. Okay, so again, this B can be placed in any of these 5 boxes. Again, C can be placed in any of these 5 boxes. So what is coming up? It is 5 to the power 3. 5 to the power 3. I hope this thing is clear. Okay, am I making it correct? Am I making sense over here? So yeah, this is having how many choices? So I'm having 5 choices for this one, because I can place it anywhere. 5 choices for second. Yeah, so yeah, 5 to the power 3. So this would have been 5 to the power 3. This would have been the stuff. Now just replace these values. We already know. So m equals 5 and n equals 3. So it is going to be mcn n factorial divided by m to the power n. Now let's just open this up. What do we get? M factorial upon m minus n factorial, n factorial, n factorial, m to the power n. This gets cancelled, and we have m factorial upon m minus n factorial, and then m to the power n. So the answer is this one. B is the correct answer. I hope the idea is clear. I hope the idea is clear. Okay, so we are considering that the objects and your boxes, object mean particle over here, and the boxes are different. Okay, so I hope you got this completely. If there is a doubt, you can just repeat, or just go back some 3, 4, 5 minutes back in the time, and you will be able to grasp the exact idea how we have solved this problem. Okay, so let's move on to the next question we are having. Again, a very simple theory based question. Okay, conceptual question. So let's see what does this tells us. So there are 2 events we are talking about, and B is the subset. Okay, subset of A, and it is a proper subset. That means definitely the size of B is less than A. Definitely the size of B is less than A. Which one of the following is correct? Then we have the arguments. Let's see. Okay, let's just create a Venn diagram as well, so that you can get to know. So okay, I have used a kind of a highlighter over here, but it's okay. This is not going to be the way. Okay, so let's suppose this is our A and this is our B. Okay, the bigger one is A, the smaller one is B. Okay, so let's just now calculate each of these things, and we can get to know like what exactly is going to be the answer for these. So let's just first of all calculate PB given A, and then we'll talk about PA given B. So PB given A is going to be P of AB, basically intersection, and then P of A. Okay, what is P of AB? Means A intersection B. What is going to be that? So as we know that B is a proper subset of A. B is a proper subset of A. So the samples, the set would be coming up would be B itself. So I'll write it as P of B divided by P of A. Okay, so up to this point, this must be clear what we have calculated. Okay, now if you remember, you just tell me this thing over here, that P of B is what? Let me just write it this way. Okay, you remember this approach, I hope, because whenever we talk about the probability, that is the kind of measure which measures the size of our given event set with respect to the sample space. Okay, always that we write it in such a way. We have already discussed about this. So this means the size of my sample space, this means sample of my B. Okay, so over here now, if I talk about P of A, what is that going to be? That is going to be something like this. And we know A is going to be lesser than or something like this. A is going to be something like this. For sure. It is definitely going to be that either A is the entire subspace, that may be a case, or A is lesser than sample space. So we know that. So this is the first equation we are having. This is the second equation. Let's just put these values. What do we get over here? So it would be size of this, and then we have, just for the sake of understanding, I am taking it further, and you'll learn it that by intuition also we get the answer for this one. So if I just cut this off, what I'll get? I'll get this. So you just tell me this thing. So value of B given A is going to be something like this. Value of P, that means probability of B given A, is going to be something like this. Just tell me, just compare it with this, because ultimately we have to compare this with probability of B. So if my denominator decreases, because sample space would have, would be having a larger size as compared to A for sure, or if it is a proper subset, then yeah, for sure it would be lesser than that. If those are equal, then it would be like equal. Over here we'll be having sample space only. So if that is the case, if A size is less than my sample space size, then denominator is less over here. And if denominator for any fraction decreases, overall value increases. We know, yes or no? If my denominator decreases, my overall value increases. So as compared to P of B, our P of B given A is going to be greater. It is going to be greater than P of B. I hope the idea is clear. And we already know this. In the conceptual. Now let's come to the intuitive part. That could be, without doing these calculation, without these kind of, formulation, we could have said that. The answer is simply yes, because if you remember the last session, we have already talked about it. That we talk about the common portion only when one event has been occurred, and overall my sample space decreases. If you remember, here was this line where I discussed it, that on the intuition level it is as if the sample space is now reduced to B. And don't get me wrong, because it's B written over here, because this was P of A given B we were talking about, and in the question it is P of B given A. Okay, there is a difference. So because B in the denominator, that's why we are telling that sample space is now reduced to B. And if I talk about this place over here, so over here it is P of B given A. Okay, so overall whenever your denominator decreases, your overall fraction increases. So yeah, that is the case over here. So that this is definitely correct over here. Okay, so this is the correct. Let's just check others. So this is for sure, it is wrong. It is wrong just because we know like it is going to be greater. So definitely this is wrong. Now let's talk about these two as well. Okay, this is important just to get a clear idea how do we solve these. So I'll just erase everything now, and then we'll discuss the rest of the option over here. So what would be P of A given B? I have to retain that diagram so that you don't forget that. So let me just create the diagram again, something like this. This was B, this is B, this is A. Okay, and this is B, as B is a subset, proper subset of A. So what would be P of A given B? Just tell me. This is very easy. This is P of AB, means intersection of both divided by P of B. And what is going to be intersection of both? It is going to be B only. So P of B by P of B, what is this value? This is going to be 1 only. So the answer for both of these, basically, it must be equal to 1. It must be equal to 1. I hope the idea is clear. It must be equal to 1, not 0. Okay, so this is also wrong. This is also wrong. Okay, because over here it was written less and over here it was 0. So it must be equal to 1. I hope the idea is clear. The question number 2 is clear. Okay, very simple problem, and we have evaluated each of the option. We have learned with the help of intuition as well. We have seen it through the proper formulation, proper equation as well. Let's move on to the next problem, the last problem over here. So this is a good problem for the understanding. Let's just solve this. So I have to create a table. First of all, I have to show you what a tetrahedral die may look like. So generally we have this 6-sided die. You have seen that, yes or no? So die is normally something like this. Oh, it's not good. I'm bad at drawing. Okay, even at the handwriting, but I hope that is not a major issue for you guys to understand. So something like that. I have to draw it this way only, so that so generally your die is like 6 faced like this, something like this. But if I talk about 4-sided dies, what would it look like? So on the overall top view would be something like this. The top view would be something like this. Okay, so these are the 3 sides which we can see, and the 4th side is below this. So it is a kind of pyramid we are having. Okay, the tetrahedral 4-sided die would look like a pyramid, in which on the side there will be 3 faces and 1 on the bottom. Okay, so I hope the idea is clear for the 4-sided die. Now let's move on to the question further. So it is being mentioned that let X be a first roll and Y be the second roll. So X is denoting my first roll when I'm rolling it for the first time. Y is my second one. And let these be the event. B is the event which says minimum of XY must be 2. Minimum of X comma Y. X was the first roll, Y was the second roll, and the number appearing would be something on that. So it says the minimum must be 2. This is B event we are talking about. Okay, and what is M? M is something like, this is the event we are talking about. This is going to be max of XY must be 3. So just tell me what is going to be this event set for this B. What is going to be event set for this B and M? Let's just write that. And just remember, in the sample space we have something like this. It would be 1 1 1 2 1 3. I'll just show you with the help of diagram also. And the maximum value I can have on this 4-sided die is 4 only. Okay, so then like the number will start repeating, then 2 1 2 2 and so on. So I can create a table for that so that we can understand. So I'll remove these things for now, because you have got the intuition for the like how does it look. So I'll create a table now which will make it clearer. Okay, let me create a table over here. So X is this way, Y is this way, and I'll just write the numbers. So it's 1 2 3 and 4. 1 2 3 and 4. Okay, so let me just mark these up now. Okay, so now you can see over here, the important point is what is going to be my event set. What is going to be my event set? So if I simply mark for the B, what is going to be my B set looking like? So B would be minimum of both must be 2. So it must be something like this, that 2 2 is fine, then 2 3 is fine, 3 2 is fine, 2 4 is fine, 4 2 is fine. This is going to be my B set. And let me just show you over here as well that minimum of both must be 2. So over here, this must be something like this. 2 2 is fine. Okay. 2 3 is also fine. 4 2 is also fine. 2 3 is also fine, and 2 4 is also fine. So this this represents our B event. This represents our B event. What about the other one? What would be my M like? So max must be 3. Max must be 3. So 1 comma 3, 2 comma 3, 3 comma 3, 3 comma 2, and 3 comma 1. Okay. So over here, if I would like to represent, how would it look like? So 3 comma 1 is this one. Okay, this one. 3 comma 2 is like this. 3 comma 3 is like this. 2 comma 3 is this. 1 comma 3 is this. Okay. So this thing represents M. Okay. Now just tell me what is P of M given B. We need to find out what is P of, just change the color, the lighter one. This is better. P of M given B, we need to calculate. So we can use both the thing over here. Okay. So P of M given B would be P of MB, that means the common intersection I'm talking about, and P of B. So you know now how you can do that. Either you can reduce it to the sizes of these set, or you can calculate the probability for each and then divide. So both the ways I'll just show you up. So if I talk about probability of MB, that means common. So what are the common portion? You can see over here, these are the common portion. This is common and this is common. Okay. Now P of MB is what, how many, such pair are there? 2 pairs are there. And out of how many pairs? Out of 16, because there are 16 possible values. 4 possible values for X, 4 possible value of Y. So overall we'll be having 16 values in our sample space. Okay. So P of MB is going to be 2 by 16 divided by what is P of B? P of B, how many number of elements were there in your B? So these were like 1, 2, 3, 4, 5. I guess you are able to see that 5 elements are present over here. Okay. So it is 5. I hope this is clear. 1, 2, 3. Yeah, B were 1, 2, 3, 4, 5. 5 upon 16. And the answer you'll be having would be 2 by 5. Answer you'll be having would be 2 by 5. Okay. Now let's just do this by another way, which is like the intersection portion, basically if I talk about directly the size of my MB set and size of my B set, what would have been the answer over there? So if I talk about size of MB, what are the common elements present over here? This is common, and I guess some more must be there. Yeah, this is common. So we have 2 in this size of MB, basically 2 3 and 3 2. These are the elements present over here. So the size of MB is 2 divided by what is the size of B set? Size of B set we already know, it is 5. So the answer is 5. 2 by 5 this way as well. So I hope the idea is clear how we could have calculated it. It's a very simple problem. We have solved this problem in an exhaustive way, considering each of the possible thing which was present over here, and then we have got the answer as 2 by 5. Okay, so these are the problems I wanted to discuss based on conditional probability. Good problems over here. Okay, so in the next video we'll start with Bayes theorem and law of total probability or total probability. Okay, we'll have a look at that. What exactly is that? And that is going to be very important. And post understanding the concept, which is my way of teaching, first of all I'll teach the concept and then some question based on that. So we'll be discussing this question as well, Monty Hall problem. Okay, which led to this kind of show which was like Khulja Simpson in India. Okay, this was a show on Star Plus. So we'll solve that kind of question as well. that okay, how we can solve that, how that is based on Bayes theorem and basically conditional probability. We'll have a look at that. So I hope you like the lesson, you like this entire session. Okay, so you can give me a thumbs up, share it with your friends, comment down your feeling, and you can join our WhatsApp channel, Telegram group you can scan, and Instagram page you can follow. Okay, so that was all, guys. Thank you guys for watching this video. We'll see you guys in the next video. Thank you.